Welcome back. We are still on the topic construction. In the previous video, we learned how to construct the locus of points equidistant from three fixed points. In this video, we are going to learn how to construct the locus of points equidistant from two intersecting lines. Locus of points equidistant from two intersecting lines. Let's consider these two lines here. We have line AB and line AC, and they intersect at point A. We are going to learn how to find the locus of points equidistant from line AB and line AC. The locus of points equidistant from two intersecting lines is the bisector of the angle formed between the two lines. In the videos on plane geometry, we learned that when two lines meet, an angle is formed between them. As we can see from here, when line AB and line AC meet, an angle is formed between them at point A. We have seen from here that the locus of points equidistant from two intersecting lines is the bisector of the angle formed between the two lines. So here, the locus of points equidistant from line AB and line AC is the bisector of the angle formed between line AB and line AC. That means that to get the locus, we will have to bisect the angle formed at point A. I'm going to represent the bisector with these short dashes. So this short dashes, which is the bisector of the angle formed between line AB and line AC, gives us the locus of points equidistant from line AB and line AC. Because this bisector gives us the locus of points equidistant from line AB and line AC, if we pick a point on this bisector, let's say this point, I'm going to call it point P, and we draw a perpendicular line from point P to the line AC, and we draw another perpendicular line from point P to the line AB. Let's call this point here point Q and call this point here point R. The distance between point P and point Q will be PQ, and the distance between point P and point R will be PR. Because this bisector gives us the locus of points equidistant from line AB and line AC, the length of PR will be equal to the length of PQ. In the same way, if we pick another point, let's say this one, I'm going to call it point X, and we draw a perpendicular line from point X to meet the line AC, and we draw another perpendicular line from point X to meet the line AB. Let's call this point point Z and call this one point Y. The distance between X and Z will be XZ, and the distance between X and Y will be XY. Because this bisector gives us the locus of points equidistant from the line AB and the line AC, the length of the line XY will be equal to the length of the line XZ. So we have seen from here that when we have two straight lines intersecting, the locus of points equidistant from those two straight lines will be the bisector of the angle formed between the lines. Now let's apply what we have learned here to solve a question. The question is, using a ruler and a pair of compasses only, construct I, triangle PQR such that QR is equal to 7 centimeters, PQ is equal to 8 centimeters, and angle PQR is equal to 90 degrees. II, construct L1, the locus of points equidistant from PR and QR. B, measure PX, where X is the point of intersection of L1 and PQ. And C, find the area of triangle RSQ. In the previous videos, we have learned how to use a ruler and a pair of compasses only to construct triangles. And so I'm not going to go through the process of constructing the triangle PQR in this video. I'll move straight to the remaining parts of the question. But before I do that, I'll pause for some few seconds so that you can pause the video and construct the triangle. Now let's begin with the solution. The first part of the question says that we should construct triangle PQR such that QR is 7 centimeters, PQ is 8 centimeters, and angle PQR is 90 degrees. That is what we have here. We have the triangle PQR. PQ is 8 centimeters, QR is 7 centimeters, and angle PQR is 90 degrees. Let's move on to the next part of the question. It says that we should construct L1, the locus of points equidistant from PR and QR. So here we are going to construct the locus of points equidistant from the line PR and the line QR. The line PR and the line QR intersect at point R. We have seen that the locus of points equidistant from two intersecting straight lines is the bisector of the angle formed between the two lines. So here, to get the locus of points equidistant from the line PR and the line QR, we will have to bisect the angle formed between them. The angle formed between them is at point R. So it means that to get the locus, we are going to bisect the angle formed at point R. We have learned how to bisect angles in the previous videos, so I'll go over it quickly in this video. To bisect the angle at point R, we will take the compass and put the needle on point R since we are bisecting the angle at point R. So you put the needle of the compass on point R. Then you turn it this way and you construct an arc to intersect the two lines forming the angle. So you turn the compass this way and you construct an arc to intersect the line QR and the line PR. After that, you move the needle of the compass to this point. That is the point of intersection of the arc and the line PR. Then you adjust the compass a little bit, you turn it, and you construct an arc. After that, with the same radius, you move the needle of the compass to this point. That is the point of intersection of the arc and the line QR. Then you turn the compass and you construct another arc to intersect the first arc that you constructed. You can see that the two arcs intersect at this point. I'm going to clean the excess part of the arc so that we can continue. So I'll clean this part and clean here too. To get the bisector of the angle formed at point R, we will draw a straight line joining the point of intersection of the two arcs to point R. This straight line bisects the angle formed at point R, and as we have seen, it is the locus of points equidistant from the line PR and the line QR. The question says that we should call this locus L1. So we have L1 here, which is the locus of points equidistant from PR and QR. Let's move on to the next part of the question. It says that we should measure PX, where X is the point of intersection of L1 and PQ. We can see from our construction that L1 and PQ intersect at this point. Their point of intersection is going to give us point X. So we have point X here. We can now measure PX. To measure PX, I'll take the compass and put the needle on point P. Then, after that, I will stretch the other part, that is the part holding the pencil, to point X. By doing this, I've used the compass to measure PX, but I want the exact distance. To get the distance, I'll take the ruler and read the measurement on it. So I'll put the needle of the compass on point 0, then I'll read the part holding the pencil. From what I have here, the part of the compass holding the pencil meets the ruler at 48. Remember that the scale I'm using on my ruler is in millimeters. 48 millimeters is equal to 4.8 centimeters. What this means is that the length of PX is 4.8 centimeters. We are done with both the compass and the ruler, so I'm going to take them off so that we can continue. Let's move on to the last part of the question. The last part of the question says that we should find the area of triangle RXQ. I'm going to make a small sketch of the triangle RSQ here. So I have point R here, point X here, and point Q here. The angle formed at point Q is 90 degrees. So I have the right angle sign here to show that the angle formed at point Q is 90 degrees. As you can see from the construction, the side QR is 7 centimeters. So QR is 7 centimeters here. Now we have to find QX, which is the base. From our construction, we can see that from P to Q, which is PQ, will be equal to from P to X, which is PX, plus from X to Q, which is XQ. We know that PQ is 8 centimeters, and we have just found out that PX is 4.8 centimeters. So if PQ is 8 centimeters and PX is 4.8 centimeters, then SQ will be equal to 8 centimeters minus 4.8 centimeters. 8 centimeters minus 4.8 centimeters will give us 3.2 centimeters. This means that the length of SQ is 3.2 centimeters. We now have the height and base of the triangle, so we can find the area. Let's do that. So we have the triangle RSQ here. QR, which is the height, is 7 centimeters, and SQ, which is the base, is 3.2 centimeters. In the videos on mensuration, we learned that the area of a triangle is equal to half times the base times the height. The base of this triangle is 3.2 centimeters and the height is 7 centimeters. So the area will be equal to half times 3.2 centimeters times 7 centimeters. And this will give us 11.2 centimeters squared. So we can say that the area of the triangle RSQ is 11.2 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we learned how to construct the locus of points equidistant from two intersecting lines. In the next video, we are going to learn how to construct the locus of points equidistant from three intersecting lines. Bye-bye.